an isolation boundary across processes. In a networking namespace, what this means is we can run programs on any port without conflicting with what's already running. Because when we attach the namespace, the networking namespace, it doesn't conflict with what is already running. Similarly, we have a mount namespace where we can mount and unmount file systems without affecting the host file system, because we are talking about a specific namespace. So that's how having a namespace prevents one container, a process running under one container, actually from interfering into another process in another container. Containers are nothing but namespaces. Okay, so containers are nothing but namespaces we are talking about here. On the other hand, a control group or a C group in a Linux kernel is nothing but a feature by which you can prevent a process eating up all your resources. Basically, it's a way to distribute your resources across all the processes. Now, with that said, now we know that what actually makes this magic possible. Well, it's not magic at all. It's just some Linux features, Linux kernel features being utilized over here. The container is no magic term, it's just a namespace. Okay? So with that, now the next question is that what do we need to make containers run after all? So before we talk about that, let's just understand that for a container, a very fundamental thing to understand is a container works very similar to a typical object-oriented system. So if we go back to our good old OOPS concepts, where we had first of all we had a template which defined pretty much the behavior of an entity, and we call that entity a class. That template we called a class, and then once we had defined that class, we could instantiate or we could create multiple instances of that class, wherein all the instances would be defined as per the template or class, and those instances were called as objects of that class. Now the same concept is applicable for containerization. Instead of class, what we have over here is something called an image. Okay, so you can think of an image as a template or a class definition. In a container image, we store a template of what actually will be packaged into the container. So just like in a typical OOPS language, our first job is to define a class. Similar to this, over here, our first job would be to create an image. An image is a class. Now, as I said, this is very similar to OOPS. Now in OOPS we had something called inheritance, wherein there was a base class from which we could derive multiple classes. And of course there was the concept of multiple inheritance and so on and so forth. We'll not go into those details, but essentially what I'm trying to tell you is that you can always start from a class from scratch. However, you have the luxury to leverage an existing base class. Apply the same concept here. We have something called a base image. We have something called a base image, and there are actually a lot of such base images available. So as a developer, we have the luxury to use a base image to build our own image. And here the concept of something called layers come in. Now containers follow a layering model. So if you see in my diagram over here, so this entire box is nothing but an Ubuntu 15.04 image. This entire box is a Ubuntu 15.04 image. However, this image is built out of 4 layers, which means that there is a base layer which is having, and again each layer is nothing but an image, and each such layer is having a ID, as you see over here, and this is a stack. Each layer is stacked upon each other, right? Each one is stacked upon each other, and there are 4 over here, and all of these 4 layers actually form the Ubuntu image. However, one thing is to be clearly considered over here. All these base images or layers, they are all read-only, and hence there is no provision to make any changes into any of the base images. What happens instead is that we can make a layer on top of any of these images. And if you see over here in this diagram, the same thing has been done. So once you take a base image, in this case Ubuntu, and you make any changes to that, what essentially happens is that none of your base images or layers are changed. Instead, you can consider that you end up creating a new derived class out of that base class. And whatever changes you make are actually happening in that new derived class. And in this case, you have created actually multiple such derived classes. And each one of them are actually containers. So in this way, we can create multiple containers out of our base image. Or I should say multiple images. I'm sorry for using the term container over here. So I would say multiple images out of the base image. Okay, and each of them are a read-write layer on top of this big layer. Okay, so you can think about here multiple derived classes being created as a result of different changes being made to the base image. Okay, so I hope this metaphor is very clear and apt over here. So with that, I would end this this discussion. In our next video, we'll go into a bit more details of Docker before we actually start doing any hands-on.